Hello everyone, my name is Fangyu Zhou, and this video is a presentation of the final project of course EEL 6825 Pattern Recognition of Professor Dapeng Wu, University of Florida. The topic of my project is facial recognition based on Haar Cascade classifier. Although facial recognition has been developed for many years, it is still a hot and promising research area in computer vision. The reason can be, first, the computers become more and more reliable, so that high-speed computation is achievable. Second, camera as an important part of facial recognition become high quality and affordable. Facial recognition can be applied into many areas, such as public surveillance system, especially for search for suspects, an intelligent man-machine interface, which is now a very hot search area, content-based retrieval, and signal video processing, and etc. Nowadays, the camera can use facial recognition algorithm to automatically adjust focus. As it has been researched for many years, many methods has been developed to achieve facial recognition. Since there are too many approaches, here listed 4 popular ones. The feature-based method like Haar Cascade classifier, which is used in this project. The image-based method like neural network and some statistics methods. Active contour model-based method like Canvas model, and skin color and template-based method. This project is first to train the recognition system and then use test images to evaluate the performance. All code are written in Python and use OpenCV as kernel library. All test images are downloaded from internet. Let me introduce the algorithm first. The whole training system works like this. First of all, we need both positive input samples and negative input samples. Then we compute the Haar-like features for creating weak classifier. Then try to find best thresholds to optimize weak classifiers. After that, use algorithm to combine several weak classifier as one strong classifier. Finally, cascade all strong classifiers to reach the desired system, which will be tested. The details will be discussed in the following PPTs. So what is Haar-like features? It can be represented as it is in Figure 1. There are 3 kinds of Haar features: the edge features, line features, and 4 rectangle features. To compute the Haar features, place any one of the rectangles above on the face area. Then subtract the sum of pixels of white region with the sum of pixels of black region. The result value, we'll call it the face eigenvalue temporarily. If we place the rectangle in a non-face area, then the eigenvalue calculated should be different, and the more the better. Therefore, the purpose of this rectangle is to qualify the face features to distinguish between face and non-face. Besides, how to combine the rectangles to make more difference between face and non-face is a task of AdaBoost algorithm, which will not be discussed in detail in this project. A weak classifier is a simple one that can tell the difference between face and non-face. After calculate the face eigenvalues, we can generate simple weak classifiers like shown in this page. For a sub-window image, if the calculated eigenvalue of the test images fulfill the threshold, the classifier will give its face judgment. If not, it will give a non-face judgment. But this kind of classifier may be too simple to get a good performance. Therefore, we need to upgrade the classifier step by step to improve the performance. The first step is to optimize the weak classifiers we just got. Scan the pre-ordered eigenvalues and calculate the following 4 values for each element in the ordered table. First, Sum of the weights of all phase samples, T1. Second, sum of the weights of all non-phase samples, T0. Third, sum of the weights of all phase samples before current element, S1. And fourth, sum of the weights of all non-phase samples before current element, S0. Then we can find the minimum R in all R's using the equation R equal to the minimum value between S1 plus T0 minus S0 and S0 plus T1 minus S1, and make it the threshold of the classifier. That will be the optimized weak classifiers we will get. The second step is to generate strong classifiers using optimized ones. T iterations are needed to generate one strong classifier. Assuming that we have X positive samples and Y negative samples, and N is represented as the total number of samples, which equals to X plus Y. For each sample, the initial weight is 1 over N. Firstly, train the first N samples to get the first optimized weak classifier, and then raise the weights of samples which are misclassified in the last step and combine them with the new samples to generate another training. Repeat these two steps for T times so that we can get T optimized weak classifiers. Finally, using the equation shown in this page to combine the T-optimized weak classifiers and get a strong one. Besides, after generating strong classifiers, we need to cascade them so that the misrecognition rate will be much smaller than any single one. From the introduction above to the hard cascade classifier, we can see that the calculation is time-consuming, and if we want high-level cascade classifier, computations will take much more time. For example, only a 24 by 24 window contains at least 100,000 features, not to mention the calculations for these values. In this case, a catalyst is required, which is called integral image in this progress. Integral image is a matrix presentation method that can describe global information. Figure 3 is an illustration of the integral image. Assume that the four corner of D is alpha, beta, gamma, delta. Then the pixel value of D can be calculated as II alpha plus II beta minus II gamma plus II delta. So why do we need this? Remember, the hard feature eigenvalues is nothing but the difference between sum of pixels of two matrices. Using integral image can achieve the computation in constant time, which solved the time-consuming problem. After the introduction to the algorithm, I did some experiments to see the result and performance. There are three people in the figure 4, and we can clearly see the front face. In this case, the program worked very well. It frames up all the front face in the pictures with the proper green frames. Figure 5 is an image of a computer game. The people in this picture is not in real world, but the system can still recognize the face in the picture because the hair-like features of these virtual faces are very similar to that of the human face, so that the virtual faces can also be recognized as a face of human. There's one person that is not being recognized because his hair covered part of the face. When the system calculates the covered part in the face, the eigenvalues may be too different from the eigenvalues stored in the system that indicate a human face. In this case, classifier in this part will give a non-face judgment, which will cause the misclassification. Let's see some more misclassifications. In figure 6, there are two people, one with front face and one with side face. In this case, the system can only recognize the person with front face, since in the training part, I don't insert any side face images to the dataset, so the system cannot recognize the side face. Besides, the difference between heart-like features of the front face and the heart-like features of side face is big enough to make a classifier give a non-face judgment. Figure 7 shows the recognition of a black people. The system cannot recognize this face in the picture because when we train the system, we compute the value of heart-like features which mentioned above. However, the value is computed as a pixel difference in the rectangle. For black people, the eigenvalues computed is too small to fulfill the threshold that the system holds. In this case, for my recognition system, face of the black people cannot be recognized clearly. I use figure 8 to do another test for it. In this image, the face of the black people on the right side also cannot be recognized even if we can see the face clearly showed in the picture with no blur. After the face recognition part, I add the eyes recognition part to the original code and try to recognize eyes in each face. Figure 9 is the same picture as I used for the first experiment of face recognition. From the output, we can see that all the eyes on the faces are correctly framed up within a proper square. Figure 10 shows some misclassifications for eyes recognition. In this figure, 2 faces and 4 eyes are correctly framed up. However, part of the nose and part of the mouth of the left man are falsely recognized as eyes. This may be because I didn't give a score range of the frames. When the system used a small sub-window to compute the eigenvalues of eyes, the nose will have a chance to misclassified. Now let's see some evaluations and analysis. For the face recognition experiment, I downloaded 150 images, 3 test group, and 50 images per group, with front face in them, and use the design system to evaluate the recognition rate. The result can be seen in this table. For the first group, all the images contain only one person with front face, so that the actual number of faces is 15. The only 2 misses of the recognition are due to kind of blur of the face in the images. For the second group, all test images contains 2 people, and 94 of them are correctly recognized. Each images in group 3 has 3 or more people in it. Because some faces in the images are too small to be recognized or the color is too dark, the recognition rate is only 90%. For the eyes recognition part, this kind of analysis is invalid because eyes on the face can either be missed or other facial features like nose or mouth have the chance to be misclassified as eyes. In sum, the recognition rate for face in an image is reliable, especially when the number of people in the images are small. Here are the conclusions. This project achieved a facial recognition system based on Haar cascade classifier, which, although the algorithm is not easy to understand, the system is easy to achieve. The system worked well for common cases, but found it hard when recognized side faces and blur faces, and some other special cases. To improve the system, firstly, we can add more samples when training, so that the classifier can have a better threshold to distinguish between the face and non-face images. Secondly, before input the image to the system, do a pre-processing, which will deal with the blurs and noise in the images. At last, here lists a part of the references I used for this paper. Thank you for your watching, and I will represent the program. Now let me introduce the code. The first line of this code is to load Haar cascade classifier, formerly trained, which will do the actual computation, logic to recognize and size human faces. And this line is to read the input image which will be tested. And this line is to convert the digital colorful image to grayscale one, which will be easy for the task to scan and analyze image. And this line of the code is to call the detect multi-scale method to recognize all faces in images using the algorithm we discussed in the report. We can see there are three parameters in this method. The scale factor is to adjust the different distance of different faces in the images. The mean neighbor is used to determine how many judgments we should take before finding the face. And the mean size is the minimum size of subwindow. Then this for loop is to frame up all faces we found in the images with grid frames. And now let's show an example. We can read the pictures in the file. Let me try. We can read the 7.jpg and do the algorithm. We can see that all the faces in this picture will be framed up in green frames clearly. Okay, and then I will add the eye cascade classifier to recognize eyes in input images. Here is to like the face recognition. This line is to load the hair cascade classifier for eyes. And then for each face we found in the picture, we add an eye detect method to find the eyes in each face and use a for loop to frame up all the eyes. Now we can see, use the same picture, the result is. Okay, now except for the three faces we framed up formally, the 6 eyes, two on each face will be also framed up with purple box. Here is my presentation. Thank you.